Hello, my name is Xuan, and my group leader is Wong and my group members are Fann, Xuan, and Huan. We're going to be talking about 2D and 3D shapes. Okay, so for points, lines, and angles, Fan is going to be presenting, and parallel lines, perpendicular lines, and related angles, Fan's also going to be presenting. For congruent figures, Xuan is going to be presenting, and for line symmetry, Xuan is also going to be presenting. For rotational symmetry, Huan is going to be presenting, and for polygons and circles, Huan's also going to be presenting, and for 3D shapes, Zhen is going to be presenting.
Okay, my topic is points, lines, and angle. And what is point? A point is shown by a dot and is used to tell a location in a space. It does not have length, width, or height, and it has also no size. And then angle is when two straight lines or rays intersect at a single endpoint. An angle is created. The vertex of an angle is the location where 2 points come together. The Latin word angulus, which means corner, is where the term angle originates. And line is long thin mark or bend. Parallel lines, perpendicular angles, and related angles. Parallel lines is two lines in the same plane that are equally spaced apart and never cross each other are said to be parallel lines in math. Both horizontal and vertical shapes are possible. Related angles. Angles that are connected to one another are referred to as related angles, such as complementary angles, supplementary angles, adjacent angles, linear pairs, vertically opposite angles, and perpendicular angles is a right angle. Now I'll pass the mic to Fatin.
Okay, so now I'm gonna talk about congruent figures. Next slide. What is a congruent figure? Congruent figures are those that can be precisely placed over each other, ensuring they have the exactly equal shape and size. The example of congruent figures are on the right, as we can see. The triangle ABC and the triangle DEF have the same shape and size. Next, I'll be talking about line symmetry. Okay, line symmetry is a line of symmetry that divides a shape into two equals. Like a square, you cut into half, then both sides of the square that you cut in half will be the same, like symmetrical parts. Also known as the axis of symmetry or mirror line, resembling mirror reflections. Any isosceles triangle has line symmetry. Examples of line symmetry are shown on the right, with square has 4 lines of symmetry and a rectangle has 2 lines of symmetry.
Now, I shall talk about rotational symmetry next. It is known as radial symmetry in geometry. The property of a shape Hence, when it looks the same after some rotation by a partial turn, an object's degree of rotational symmetry is the number of distinct orientations in which it looks exactly the same for each rotation. Next, I also shall present about polygons and circles. Next, please. A polygon is a plane figure made out of line segments connected to form a closed polygonal chain. The segments of a closed polygonal chain are called its edges or sides. The points where two edges meet are the polygon's verticals or corners. Well, a circle is a shape consisting of all points in a plane that are at a given distance from a given point, the center. The distance between any point of the circle and the center is called a radius. I should be done presenting. Let's move on to Zhen Hoong.
Last but not least is shapes, plans, and evaluations. Our learning objective is being able to tell the side, top, and bottom view, able to recognize the vertices, faces, and edges properties of 3D shapes in solid form. Like here, yeah. Okay, the face, a flat 2D shape surrounded by edges and vertices. Face of a shape. The edge is a straight line where two faces meet and connects two vertices. Yeah, basically the line of the shape. Vertex, a point where two or more edges meet like a corner, so it's like a point, yeah. Vertices, faces, and edges are the three properties that means any three-dimensional solid. A vertex is the corner of the shape. A face is a flat surface, and an edge is a straight line between two faces. 3D shapes are defined by their perspective properties such as edges, faces, vertices, curved surfaces, literal surfaces, and volume.
Okay, thank you for listening to our presentation. Here are the credits. The instructor is Zhen Hoong. Slide 3 to 6 is in charge by Fann. Slide 7 to 10 is Xuan. Slide 11 to 14 is Huan. And I am going to be doing the video editing. Thank you. Bye.